Hey guys, welcome back. So today I wanted to do a video on the normal distribution, and we're going to look at the empirical rule, so kind of the percentages you find in the normal distribution. So let's get started. Okay, so what's a normal distribution? So basically the normal distribution, like it's written here, is just a common pattern that can be found in many natural phenomena. So if you measure people's heights, that's going to be normally distributed, and a lot of the time scores on a test can be, not necessarily always. It's also known as a bell curve, and what distinguishes a normal distribution is that most values are clustered around the median and the mean, and usually there are fewer values at the extremes. So here you can see I've got an example of the distribution of NFL players at retirement age, so basically when they retire, and how many of them. So I just pulled this off the internet. So you can see here that it kind of forms a bell curve with most players retiring around the 33 age, and less so at the 25 and 43 mark. On this right-hand side, I've got another normal distribution with the age of Nobel Prize winners. So they tend to win them around 60, at the age of 60. Okay. Now, not everything is normally distributed. So here you can see that my chart represents the median superbalance. That just means how much money they have in like a retirement fund. So most people have the most money around this 65 to 75 age. Obviously it makes sense because the longer they work, they're going to save more money into that fund. So here, this isn't normally distributed, and this has actually got a skew on it, which we can cover in a different video. All right, so the empirical rule basically says that you kind of have a few different scenarios. So for example, starting with this one, 100% of all the scores will be under the curve. That kind of makes sense. Now, if the middle is the mean or the median, 68% of all the scores or all the results are going to lie within one standard deviation. So here, that's one standard deviation to the right, and here, that's one standard deviation to the left. The next rule is the 95% rule. So basically, all the scores within two standard deviations lie between 95%. And lastly, the 99.7 rule is that within three standard deviations, you'll have covered 99.7% of all the results. Now remember, standard deviation just measures how spread apart the data is. So just think of you can also think of it as the distance from the average or the distance from the mean. So just to make things simpler, what do we notice? The 68, 95, and 99.7 rule can actually just be broken into these four numbers. And because it's symmetrical, we can just apply it on either side. So if we just look at the 68% rule first, within one standard deviation, there are 68% of all the scores. You cut that in half, it'll be 34, 34. The 95% rule just says within two standard deviations, you've got 95% of the results. So if you just basically do a bit of adding and subtracting, you end up with 13.5% here and 13.5% here. So these four numbers will add up to 95%. And then lastly, the 99.7 rule. So basically anything within three standard deviations is going to add up to 99.7%. So this, and these ones will add up to 99.7. And anything bigger than three standard deviations will be only 0.15%. And anything less than three standard deviations from the mean will be also 0.15%. Okay, so let's have a look at a concrete example so hopefully you get a better picture. Okay, so this question says a group of school students has a height that is normally distributed with an average of 170 centimeters and a standard deviation of 8 centimeters. So here you can see that the average is at the middle, 170, so most people are about 170 centimeters tall. One standard deviation is 8 centimeters, so the next one up is 178, so that's plus 8, plus another 8, plus another 8. So let's have a look at the questions. It says, what percentage of students have a height between 162 centimeters and 178 centimeters? So if we just look at the diagram here, 162 is one standard deviation below the mean, 178 is one standard deviation above the mean. So these two added together, 34 plus 34 is equal to 68%. Okay, question B is, what percentage of students have a height less than 162 centimeters? So I just go ahead and find 162, that's here. So it's going to be all these values less than 162. So 0.15 plus 2.35 plus 13.5. Pull up the calculator. Okay, so 0.15 plus 2.35 plus 13.5. So 16% of students have a height that is less than 162 centimeters. Okay, so before we move on, I just want to kind of stress the importance of remembering these numbers. It just makes it easier to work these questions out, because a lot of the time you're only going to get these three numbers, which is normal, 68, 95, 99.7, but I think it's just easier to remember these four and apply it to the other side, because remember, it's mirror image. Okay, so the next question says, if a random sample contains 3,000 students, how many have a height between 154 and 186? Okay, so this time I haven't written in the percentages, so I'll go ahead and do that first. There's 0.15. Okay, so let's have a look. So how many students have a height? Well, what percentage of students have a height between 154 and 186? So 154 is here and 186 is here. So it's just everyone between here. Now you notice that that is actually just going to be the 95% rule. So within 2 standard deviations. So straight away I can just apply that rule. So 95%, and because I got 3,000 kids, I'm going to times that by 3,000. So 0.95 times 3,000. So I should have 2,850 students between those heights. Okay, let's look at the next one. How many students have a height between 146 and 178? So let's highlight those between here and here. So you can see once you highlight it, it just becomes very easy to add up. So I'm going to go ahead and do that. So it's 2.35 plus 13.5 plus 34 plus 34. So 83.85% have a height between those ranges. And I'm going to times that by 3,000 to get the number of students we should expect. So, don't know what's happening here. So 0.8385 times 3,000. So you should expect around 2,515.5. So we're just going to round that up in this case. Okay, so that's how you'll do that question there. Okay, last question. Chip packets, are they fairly labeled? So the question says, a packet of chips is advertised to weigh 500 grams. However, after conducting several tests, the actual weight was found to be normally distributed with a mean of 490 grams and a standard deviation of 10. Based on the information, we can answer the following questions. What percentage of packets would have a weight below the advertised amount? All right, now, before I even attack this question, I'm just going to quickly draw out the bell curve. And I'm going to also put in the mean and 3 standard deviations above, 3 standard deviations below, and fill in all the percentages. Okay, put in my average there, so that's 490, because that's my mean. And I'm going up by 10 grams each time, so that's going to be 500, 510, and then lastly 520. That's 3 standard deviations above. Now below, so 480, 470, and 460. Just extend that. And in red, I'll put my percentages, so 30. Okay, now I'm done, and I should be able to answer the questions pretty easily. So what percentage of packets would have a weight below the advertised amount? So the advertised amount is this, 500 grams. So what percentage is below? So it's going to be all of this. Okay? All of that. Now, instead of adding them all individually, remember halfway here is 50%. So straight away I can just say 50% and then plus this 34. So question 1 will be 50% plus 34%. That's 84%. Okay, last question is, do you believe this product is fairly labeled? Explain your reasoning. So the chip packet is advertised to be 500 grams, but what do we notice? On average, the chip packets are weighing 490 grams. That means 50% of packets are below the actual amount. In fact, 84% are below the advertised amount. That means if you buy chip packets 100 times, 84% of those chip packets are going to be less than what they advertise. So clearly that's not fair. So in other words, if you bought 100 packet of chips, only 16 packets are actually going to be what they advertised at. So in essence, no, not fair. 84% are below the advertised price. Okay, so we'll stop that here today. Hope you found that helpful. If you have any questions, let me know in the comments below. But otherwise, I'll see you in the next one.